Okay, good afternoon and welcome everybody. Thank you for joining us for today's webinar where we will discuss the path to neural grids. Let me get some housekeeping stuff out of the way first. This webinar is being recorded, so all participants are on mute. Chat for the webinar is disabled, but we do encourage you to ask questions, and you can do that by using the Q&A button at the bottom of your screen. We'll do our best to answer all your questions at the end of this presentation. Now I want to take a quick moment to introduce your speakers and then we'll jump right in. Presenting today, we have Al Mahesh, who is responsible for business development, and Zach Llewellyn, who is principal solution architect. Both Al and Zach are from Verizon Emerging Technologies Division. Joining them today is Giovanni Polizzi, who is the VP of Sales and Marketing for Minsait ACS. I want to thank our presenters for putting this together today, and thanks to everyone for joining the call. And I think, Gio, with that, I'm turning it over to you.
Thank you, Delana. Thank you very much. Hello to all our guests and to our partner Verizon. And thank you to everyone for attending this webinar. So the opportunity of technologies such as 5G or LPWA, we'll hear about it today, are bringing to the market are incredibly interesting. So after introduction by Verizon on the technology and how they are deploying it specifically for the utilities, we'll spend the second part of this webinar going through the application to specific use cases, referring where applicable to software application and Minsait ACS as in their portfolio. We shall then answer a few questions that may have come from our audience. So now please welcome Al Mahesh and Zach Llewellyn from Verizon. Al, the floor is yours.
Thank you, Gio. I appreciate it. And thank you everyone for attending. Thank you for giving us your time. My name is Al Mahesh. Let's go to the next slide, please. All right. One thing interesting about the future, and as you can see, I've got gray hair, is that future always happens. When we plant the seeds, it will always germinate. And seeds of grid transformation were planted by just Smart Grid 1.0. And what is making this future happen are the development of the enabling technology. What are those enabling technologies? First is your connectivity, 5G, mobile edge computing, that's your connectivity. And this sensing, I always say that a meter is not just a cash register, it's a sensor. And the measurement technologies along with sensing is going to enable basically the movement towards a smarter grid. The next enabling technology is going to be drones, robotics, and cloud. You know, everything is on the cloud now. We work on the cloud. Cloud used to be something very, very different. And the perception was different. Now, everything we do, our banking, everything is in the cloud, right? Then comes artificial intelligence. Artificial intelligence is going to drive a lot of predictability and planning of the grid in the future, demand side planning, etc. And then cybersecurity. All this would never happen if we did not have robust cybersecurity. Why is this necessary? You know, the grid is going to require a lot of situational awareness. And in order for us to have situational awareness, we're going to need reliability and resilience. Next slide, please. You know, I'm going to let the academics argue on the definition of the neural grid, but I'm going to bring certain facts to you. The International Energy Agency estimates that between 2012 and 2035, there's going to be $7.2 trillion, $7.2 trillion worth of investment. 40% of that investment is going to be in replacement of what is the infrastructure that is already there. And 60% is going to be the new build. Why is this replacement so necessary? Because the demands are changing, our consumers are changing, we are becoming prosumers, we are determining what we want in the grid, and this replacement is going to require robust and low latency communication. Next slide, please. So let's take a look at where we were, where we are today, and where we are going to be. The traditional grid, of course, electromechanical, one-way communication, basically dumb grid, so to speak, not to insult anybody. But as you came to Smart Grid 1.0, there was pockets of connectivity and automation. For example, AMI is one of those pockets. Load distribution automation is another pocket. Load shedding, that's going to be another pocket, but it's not fully automated. It's not fully connected. The grid is not. So the next thing that we're going to look at is widespread connectivity and widespread automation. I was at one of the IOUs, and they had a smart home. They had a microgrid in their research center. So all this work is already being done. What the decisions that you make today about your grid are going to most likely become irrelevant in 3 to 4 years. Next slide. So this is a slide that Verizon did not put this slide on. This is a slide that was put by SCE, Southern California Edison. It takes us through the journey of AMI 1.0 to AMI 2.0, and then basically 5G and MEC. And my colleague, Mr. Zach, is going to be talking a lot about the 5G and MEC and why Verizon feels that that's the enabling technology that's going to be essential.
So Giovanni, if you want to go ahead and go to the next slide there for us. So when we look at Verizon and our position in the future of these connected utilities, we've been launching things like platform as a service, cloud applications, and a lot of other products and resources and things like that that utilities are able to use. But that's really built on the backbone of what Verizon's always delivered. And that's a communication network that really can't be rivaled by many others. So if you want to go to the next slide, Giovanni. That all starts with investment. So you heard Al talk, a little bit about this $7.2 trillion over the next, few years here that is going to be deployed in the network. Verizon's a part of that investment. Since 2000, we've invested over $164 billion into the network. And in just 2021, $53 billion of that was purchased in new 5G spectrum. And a portion of that $53 billion, about $8 billion was to buy a prime level of the spectrum. So when we look at deploying these new network technologies and really being invested in the network, you need to look at partners and solutions that are investing alongside of you, not just coming to you for that investment. Next slide on there. So when we look at networks and we look at a diverse network strategy, and make no mistake about it, in order to effectively deploy a smart grid and really, as Al kind of illustrated on his last slide there, to be able to deploy the new technology and things like that that are approaching the network, you really need a diverse network strategy. And, if you look at it, there are multiple ways to do that. You can do it through something, like an unlicensed 900 megahertz. You may have some old PLC that's out there. You may have some TWACS that's out there. You may have some cellular that's out there. But really, when you go to a network provider, for that, you want somebody, that's going to be alongside of you the entire way and develop multiple diverse networks for you to be able to take advantage of. And so when you look at the networks that Verizon supplies that'll be used by utilities, you kind of look over here on the left-hand side, there's this narrowband IoT. It's a real small message protocol network type of data, very low bandwidth. You get into the CAT-M1, this is more of where, like simple things like metering, are going to live there a little bit more than a message-based protocol. You may have some over-the-air programming, things like that that are going to, need a network with just a little bit higher bandwidth than what that narrowband offers. And then you start to get into maybe what the networks that we're all maybe a little more familiar with. You have the 4G range, which is going to range, in kind of what you would consider a typical broadband connectivity. that 25 megabyte, maybe up to a gig if you're, lucky in some scenarios. Then you start to get into this new thing that's come out, this new news article that you've probably read about with this thing called 5G, right? And when we look at 5G, you'll notice 5G starts to get broken down into multiple pieces the same way that the LTE networks have been broken down into. And that's really a low, mid, and what Verizon calls an ultra wideband range. And you'll see there that there's a lot of different capabilities of the network, which means for you as the end customer, there's a lot of different technology and resources that can be deployed on those networks. And I think it's very key that we look at those, because when you look at things like an application that you use on a daily basis, moving to the edge, moving closer to where the customers or to where the end device is, you really need that high bandwidth connectivity for some of those applications. You really need that nearby compute and storage resource from the cloud that Al alluded to earlier. And really the best and only way you can do that is to have a blended range of networks. And that's really what Verizon's network deployment strategy has kind of followed along there. And so you'll see over on the other side, there's dimensions of LTE. We've talked a little bit, about speed and throughput over there. You've also got things like security. So, when you're looking at some of the things that have happened to networks in the past of different utility industries being attacked, your information is under siege every day. I've seen some staggering numbers for the amount of threat attacks that happen every day that are thwarted. And you want partners that can provide you with something. If you look at, unlicensed or unencrypted networks, there was a story in Texas about a hacker that was hacking after the freeze going through of these unencrypted networks. Now, thankfully, this was a nice hacker, a friendly hacker, if you will, an educational hacker. But if it's that easy for the good guys to do it, we know that it's that easy for the bad guys to do it. Some of these networks are also low power, so from an environmental, perspective, they're requiring less and less of the device, meaning batteries last longer. They're more efficient, they're more green. We're able to use things like solar or wind generation now to be able to supply these networks, where previously we had to rely on some fossil fuels to supply those, or fossil fuel generators to back those up. More and more of those are being moved to different generation resources. So there's a wide range of things that are coming together from LTE to be able to provide these network solutions to customers. Next slide, Giovanni. So when we look at 5G, 5G is the next evolution of a network. And really, 5G and 4G are kind of becoming a more blended sort of network. We had the 1G network 20 years ago, basically just voice over the air. And then when you had 2G come out, that started to add text data. 3G was the first one where we really had data, over the air. And then now with 4G, this is 4G, we have video there, but 4G is really what enabled application. And that's really what has driven technology forward. And shortly after we launched 4G, this new term came out for LTE, long-term evolution is what that stands for. And 5G is a part of that long-term evolution strategy. So what 5G is 5G is a high-capacity supplemental network that's meant to work in conjunction with these other networks. It's really the first network that allows true slicing. And it really allows for that higher bandwidth. If you're looking at video usage or near real-time latency on applications, these autonomous decisions that can be made by AI or applications, and I know Giovanni is going to allude to some of those a little bit later. You need those networks that are at the edge and deployed, where typically something like maybe fiber is either too expensive or too regulated in certain areas to be able to build out. We all look at, like around a national park or something like that. If you can't build fiber directly through that park, but you have services that need to be served there, you have to have supplemental networks to be able to bring that together. And so 5G is that supplemental network above and beyond 4G that really takes those applications, makes them autonomous, but also moves them closer to the edge. Next slide on there. And so when we look at the architecture of how Verizon is designing some of our own applications, we've designed our own AMI network on there. But we also look at things like our multi-access edge computing partnerships with Microsoft Azure and AWS. And we're looking at, truly building in these local MEC centers into our network that allow you, the customer, to have those applications out there utilizing storage and compute and things like that to make those real-time decisions, to enable those AI solutions, to enable those applications to run on the edge. So from an architecture standpoint, you see the network over there on the far left that's very close to those endpoint solutions, those sensors, those meters, everything that can be deployed out there in the field. And whether those are connected directly on a cellular network or whether they're backhauled through a cellular network, cellular is becoming a big part of that. But then over there on the right side, that's where you start to get into hosted applications, platform as a service, really kind of moving some of that stuff off of the on-prem. And then down in the bottom is where you get into those MEC centers. And that's really where we look at, the next generation of technology, where Verizon is kind of taking on that incumbent part of the on-prem. And we're building that into our network organically and making that available to customers. So that hopefully gives you a little bit of an idea of how these networks start coming together, how you can see a 4G and LTE metering communication, communicate with a platform as a service, but then also how some of those next generation things will use the 5G network and will use the MEC operation centers within the 5G network to actually enable those applications for utilities going forward. And Giovanni, I think with that probably turns it over to you next.
Thank you very much. Thank you very much, Al. Thank you very much, Zach, for the information that you shared. So in the next 10 minutes, I will explain where we see the short-term opportunities for utilities to leverage more data, to make use of lower latency, and to rely on data with finer granularity. So this is, of course, we're talking about much more data, faster data, and more granular data. So the first use case that we want to talk about has to do with the better management of outages. So if we want to improve outage management, basically what we have today is smart meters that are able to send more data with lower latency and provide much better information to identify, for example, the areas of the grid that are affected by an outage. This information is essential for field crews, right, to reach faster the origin of the outage and to restore power supply. And by the way, the same crews can leverage the 5G network and to receive information directly on their devices to be informed at all times at the control center or dispatch center about what is happening in the grid, in the area surrounded, in the surrounding area where they are operating. So more data, however, also means more ways to avoid the false alarms. By means of data processed at the concentrators, for example, then we can spot incoherent outage information and avoid triggering unnecessary alerts. And we saw in the presentation before that Zach was talking about the IoT gateways. So the IoT that communicate with the distribution automation devices or with the smart meters. So parameters like SAIDI and SAIFI are affected by how fast power can be restored and how frequently power supply is interrupted. So faster restoration and the lesser number of outages can be obtained with more automation, with more data collected from the field. So both these initiatives require low latency and competitive prices for bandwidth and traffic. The more data, of course, the more traffic we generate. So OEM, normally in collaboration with partners such as Verizon, can develop and deploy retrofit solutions to enable 5G or LPWA communication, thus enabling wireless communication among field devices and with centralized systems such as OMS or SCADA. So this is something that is very important in the collaboration with Verizon because being them one of the leaders in the market of course OEM so manufacturer basically of field devices and field automation will have an interest in developing a retrofit solution with Verizon. So power restoration can therefore be faster because so much more data can be managed at any one time before and during an outage. So we really have, this is our first use case. The second one that we want to talk about is the informed operation of a thorough monitor grid. So again, power delivery can improve in a number of ways. Power monitoring, for example, and the ability to forecast conditions that can potentially generate issues on the grid are the pillars to better grid management. We consider that the forecasting when we saw the Al was showing three different types of grid, we have the first one, what he called the dumb grid. It's probably a reactive grid, right? A grid that would react to situation. Now, when we talk about situational awareness, it's a grid that is actually able to forecast and avoid events, negative events in the network. To do this, of course, we need capacity to forecast conditions. So more monitoring, first of all, and this more monitoring requires more data points, but also more near real-time interactions. So more automation and more capacity to dynamically reconfigure power distribution. As load increases, operational ranges become tighter. Decision must be taken rapidly but effectively. So the traditional seasonal setting approach that is normally used in protection and control, for example, in network, the set and forget or the automatic settings are becoming a new limiting factor. In a grid that is way more dynamic, and that it was 10 or 20 years ago. So similarly, relying on all the time on the human in the loop, as well as centralized system, is also becoming a limiting factor of correctly managing the grid or effectively managing the grid. We are seeing a growing need to distribute capacity, the capacity to process data and to take autonomous decision to reconfigure a section of the grid, not the entire grid, just a section of the grid that are more affected by negative events. So again, however, this requires more data. So this requires more data and faster data. For example, peak loads put aging assets under great stress, increasing the risk of failure. So if we know the health of our assets, and some assets have been out there for 20, 30 years, so knowing the health of assets helps redirect larger energy flows towards assets that are in better condition than others. So not all assets are basically stressed the same way, or not assets can withstand stress conditions in the same way. Minsait ACS, for example, integrates a one-side APM with metering data and with SCADA data to calculate the health index of assets, such as pole transformer, breakers, line voltage regulators, switches. To forecast the entity and the location of peak loads, Minsait ACS collaborates with utilities, proposing one-side intelligence, using metering data and other data from distribution automation and weather forecast. So we know exactly what's going to happen in the network 24 hours ahead, for example, and we know exactly when the peaks are we forecast where the peaks are gonna occur in which part of the network. Although we have a peak in a system level, that doesn't mean that the entire system is at its peak. Some parts are probably more stressed than others. And this is what the forecast information will have to provide utilities. Of course, we need data, historic data from meter. We need the real-time data coming directly from meters or directly from SCADA. So we can give a very complete survey of the evolution of demand to cover the hour ahead and all the way to 24, 48, 72 hours ahead of the operations. And we can give an hourly forecast of load, which is a very important information for those who run the control center. The next use case is, of course, the integration of DR, distributed energy resources. Again, more DR do require more data and do require faster analytics. We have greater amounts of DR that determine today high variability of demand during clear days and cloudy days, as well as before sunset and after sunset. So the reconfiguration of the network to prepare the infrastructure to rapidly increase power flow is paramount. Utilities must be prepared when sun goes down, basically demand goes up because of the masked load, because of the load that is supplied by PV panels or by energy storage. So the combined use of metering data, distribution automation, energy storage can avoid a lot of strenuous operation on the grid. And this is the target of the solution that we propose with One-Side Grid. Loads can be managed and modulated when they are connected to DERMS platform, which can manage island of demand and the generation. We're doing a project in Colorado with NREL, the National Renewable Energy Laboratories, and Holy Cross, the cooperative there in Colorado, in Aspen, Colorado. And what we're actually doing is exactly this, connecting as much as much renewable that we can, and basically splitting the entire network into self-sustained islands. And this increases dramatically the resiliency under extreme conditions and extreme weather conditions, but also can decrease the peaks by communicating these islands of balance one with the other by transferring energy from one place to the other. So the mass load generally served by PV and behind the meter energy storage can be evaluated in real time, and utility can set countermeasure to avoid the sudden surges of demand in presence of fast-moving clouds, for example. So one-site utilities grid, this is the solution that we provide, is our platform that includes modules of SCADA, OMS, DMS, and DERMS that can leverage DR data with fast and distributed data analytics. And then I want to tell you about how a utility can make use, again, I'm trying to refer to the short-term solution. So how can a utility immediately evaluate the value that the solution will bring? We propose a POV, a proof of value. And this is the way we promote collaboration with clients and with partners. So we're starting with the proof of value. With the metering data that is already available, clients can simulate where the solution would work best. So having appreciated the value of fine granularity and blending field data with metering information, so we're bringing in data from SCADA, from system, from distribution automation, and together with the metering data, then clients can appreciate the value, capture that low latency can bring and finer granularity can bring. Therefore, testing the use cases for their particular context, and once they are finally tuned, then ramping up the size of data sets. So rather than starting with a portion of the network, then you use the entire data sets that is available. You extend the automation, so you bring in more data points in the network. There's more configuration of the network to be run. But basically, by ramping up data sets and the capacity to process data, that's when the use case becomes much more interesting. And lastly, consolidating the learning by deploying the use cases across the power grid and starting to monetize that investment. So these are three very, very clear steps that we promote. Of course, from a software platform point of view, those are the different distribution in time. Of course, if you have to deploy a communication network before that, then of course between month 5 and 12 is where probably that period is going to extend for the deployment of a communication network. But having 5G reaching your area, probably the best way to ramp up that communication capacity. And the retrofit solution that I was mentioning before is probably the best way to immediately capture the value that the technology that Verizon is deploying across the nation will bring to utilities. And the last, just a brief introduction on Minsait. Minsait, we are expert of utilities and have a very complete portfolio of solution testing in many implementations that cover pretty much any process within the utility, from the generation down to the distribution, customer billing system, and metering. We believe strongly in the partnership with Verizon. We've been working, we're presenting solution to customers for now a number of years with Verizon to our customer in the US. And all our solution integrate, all our solutions are based on one common technology called the Minsait platform. And we're able to leverage software distribution through containers, through IoT, and deployment on premises or in the clouds. And this fits pretty well with the strategy that Verizon was describing before, using a cloud service provider, using IoT, using a concentrator to become the places where we elaborate data, where we process data, so that we don't always have to go back and forth from centralized system. That is the value that we can bring with that platform that is already IoT ready. So we hope to have generated interest in the participants, and we look forward to hearing from you through questions if we have received any questions, or in the coming weeks for more detailed presentation how Verizon and Minsait are collaborating for the utilities and with the utilities. So Zach, I don't know if you want to add something to the presentation. but we are here.
Thank you, Giovanni.
Okay, guys, it looks like we had a few questions come in. Again, to the attendees, if you have any questions for our presenters, just use the Q&A button at the bottom of your screen and send those over. Speak now or forever hold your peace. We've got them on the line. So, all right, looks like the first one is going to be Verizon. So Verizon is moving to 5G. So how do we know what we deploy won't be end of life like 3G is becoming this year?
Yeah, I can take that one. So, we alluded to this a little bit, right? Of 5G being a supplemental network and this long-term evolution network strategy. And really, this is where, we talked about a network being, a supplemental network and not a replacement network. So Verizon, has the most awarded network in the US, and it has been, recognized multiple times by Root Metrics and JD Power for their network. And, the network itself, like I said, is really not built in terms of LTE and 5G going forward to retire networks as much as it is to start building supplemental networks on top of each other. And that really kind of speaks, I think, to what the utility industry has been doing for quite some time now, because, as we've looked at it, networks have always kind of been deployed in these diverse strategies at the utility level. And now we're seeing the cellular network evolution kind of evolve with that. So no longer are networks meant to be a retirement of a previous network. They're just supplemental to the previous networks that are already there, and they're bringing new technology along with those networks.
Okay, Al, do you have anything to add, or Gio?
Well,
No.
yeah, so like Zach was talking about, this is a question that comes to us almost all the time when we present. The difference between 1G, 2G, 3G is they were all generational technologies, and it required a rip and replace of the network. When we started 4G, it's called evolutional technology, more software-based rather than hardware-based. So the standards today in 5G are for the Cat-M network, where we have a lot of our utilities at, are the same standards that are in the 4G. So even if we were to retire anything, it's going to be 20, 30 years before anything is retired. And I think the biggest contract we've written is about 15 years.
Okay, great. Thanks, Al. Thanks, Zach. All right, next one is, how do 5G and other new networks impact the utility industry?
Yeah, so as we look at how 5G really impacts the utility industry, and we talk about a lot of these things, right? AI and machine learning. We talk about applications. We talk about cloud, and there's a lot of these new technologies that are coming out that previously required very capital-intensive networks to be built out, whether that was Wi-Fi or fiber or things like that. And that traditionally they really didn't build much, in terms of outside of the four walls, of a utility. And as we look at how smart homes and smart thermostats and DER and moving to carbon neutral and zero footprint and these types of industry trends that are happening, we really need networks that can deliver the same thing that we would get maybe inside the four walls traditionally on some of the high capacity networks, but we need that network out in the field. And so 5G really opens the door there for those applications, for cloud and things like that, to really move, into the, into the edge, into where devices are, to where customers are, to where solutions need to be. And so that's really what I think 5G brings, to the utility industry, is the ability to start looking at those, what were once thought of, kind of, I'll steal a line from one of your slides where you said, what you deploy today may be, relevant in 3 or 4 years. Well, that's what 5G is really enabling, is customers to be able to build technology that they know can last into the future, to make those decisions on things because they know this network's going to be around. They know the network has the capacity for it. They know the network has the low latency that they need for these new applications, and to be able to take those further into the future. And I think that's a big reason why Minsait and ACS have looked at, and Verizon have looked at each other as partners in this, is we see the value in coming together, with these applications for customers, with a one-site platform combined with, some of Verizon's platform as a services, and really, moving those onto a transformational network like 5G.
Yeah, there's one word called instantaneous. Instantaneous voltage, instantaneous demand. That's going to be enabled by 5G. So that's how, instead of after the fact, you'll get instantaneous ability to monitor your voltage and also your demand. So that's a good word to use, instantaneous.
Thank you, Alan. Yeah, and I also like to express, the same thing is that at the end of the day, we are seeing this the low latency being a great value because of the distribution automation that is required and the need for a rapidly changing configuration of the network under different working conditions. We're seeing today with the high demand because of the heat waves, how strenuous the work of balancing demand and generation is becoming in the grid, and with the increment of technology such as electric vehicle and electric vehicle charging station, there's going to be something that is even more challenging for utilities. So being able to monitor that network across different systems, not only the SCADA, but across different systems, and being able to take autonomous decisions in different portions of the network, thanks to the reliability of the communication through 5G, is going to be a game changer in the future in the way we run the network, in the way even DERMS platforms are going to be deployed as autonomous islands of balance.
Okay, great. Thanks, guys. All right, let's see. We've got, why should I use Verizon Cellular over other cellular or RF networks?
Good question. I'll leave that to you guys.
Yeah.
I know why.
Yeah. So from a competitive conversation, I love it. So really, when we talk about Verizon and what makes our network valuable, we've got a list of awards. I talked a little bit about how we're the most awarded network by RootMetrics and JD Power. But when I look at that diverse network strategy, and you look at the competitive landscape that's out there, take the other cellular, providers and things like that, and even move them out of this part of the conversation. But when you typically purchase a communication network solution, the burden of that communication network typically moves, from the seller to the buyer, and that buyer is you. And so if you're the buyer of that network, you have to maintain and support that network. I talked about that $164 billion investment, that Verizon continually puts into its network. We are continually doing a fully hosted and managed network for customers, with the large breadth of our resources globally that we pull together to be able to provide solutions to customers. And then we look at, from a technology and transformation standpoint, we thought that there was a value in being first to 5G, but that wasn't the only value that we saw in 5G. The other value that we saw in 5G was delivering the better network on 5G. And so that's why Verizon has strategically purchased the spectrum that it has and purchased prime spectrum within that to reduce things like interference and have, bandwidth available for customers. To not just, we talk about a cell phone as being a transactional relationship. When we look at these new, technologies outside of just a cell phone operating on a network, they're really transformational. And you need a partner that's looking at the entire industry and technology as a whole, and really looking at that and saying, how can we transform with what our customer needs are? And that's really, I think, where we at Verizon separate ourselves from some of the competition out there, is we have that strategy. We have that looking glass into the future that says we needed to be developing our networks in a way and purchasing spectrum in a way that sets us up to deliver those solutions to meet customer needs. And then along with that, we'll keep trying to stack awards and trophies so that we can, share those.
All right, Al, you got anything you want to add?
No, I'm good.
Okay, good deal. Well, that actually looks like all the questions. So I guess they're picking on you Verizon guys today. I want to thank everyone again for joining us, and thank you again to Al, Zach, and Giovanni. Al and Zach will actually be joining us this September 18th through the 22nd in Orlando for our 44th annual customer conference, so we hope to see everyone there. You can get more info on that at minsaitacsconference.com. Last thing, once you sign off, there will be a quick survey that pops up. Just take a quick minute to let us know how we did. Thank you again, and have a great rest of the day.
Thanks,
Thank
everyone.
you. Thank you.
Thank you.
Thank you. Bye-bye.